June 2023 Physical Science Paper 1, starting from question 4 exam. So we are told that trolley A of mass 7.2 kilograms, sorry about that, moves to the right at 0.4 meters per second in a straight line on a horizontal floor. It collides with a stationary trolley B of mass 5.3 kg. After the collision, the trolleys lock together and move to the right as shown in the diagram below. Ignore any frictional effects. 4.1. We are asked to state the principle of conservation of linear momentum in words. Now, for the principle of conservation of linear momentum, you need two key phrases also. You also need you need two key phrases. The first isn't really a key phrase, but it's a word. The first being isolated, and the second being total linear momentum is conserved or remains constant. Now, how do we tie that in together? You would now come and say, when they ask you state the principle of conservation of linear momentum in words, you would then come and answer, in an isolated system, the total linear momentum is conserved, or you would say, in an isolated system, the total linear momentum remains constant. It is also acceptable to say in a closed system rather than in an isolated system. 4.2. We are asked to calculate the magnitude of the velocity of the trolleys immediately after the collision. All right. Now let's take the right as positive. Let's take right as positive, okay? Our formula tells us that the sum of the initial momentum is equal to the sum of the final momentum. Now, when we expand this, it is then m of the mass of trolley A times the velocity, the initial velocity of A, plus the mass of B times the initial velocity of B is equal to, now remember what it says, remember what our statement says. Our statement tells us that after the collision, the trolleys lock together and move to the right, meaning they move together at the same speed VF. Okay, in this scenario, V of BF is equals to V of AF. They move together at the same speed because they are locked together. Therefore, what you write is the mass of trolley A plus the mass of trolley B, all multiplied by the final velocity. Okay, we know their masses. The mass of trolley A is 7.2 kilograms multiplied by its initial velocity, which is to the right, 0.4 meters per second, positive because it is to the right and we have chosen right as positive, plus the 5.3 kg that comes from trolley B multiplied by 0 because it is stationary initially, is equal to 7.2 plus 5.3 VF. Finally, you find that VF is equals to 0.23 meters per second. You could have tried and found it in a different way where you use the change in the momentum of the trolleys. Okay, you would say or this is a different solution. This is a different way of reaching the same solution. You would say delta momentum of A is equal to the negative of delta of the momentum of trolley B. Okay, remember we have taken right as positive because the 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 the, 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 the sum of the changes in momentum of the two trolleys will equate to zero. That is what conservation of momentum initially tells us. Okay, so what I am saying is it tells you that delta P of A plus delta P of B is equal to zero. This is the conservation of momentum, okay? Which is why you have this formula that tells you that delta P of A is equals to negative delta P of trolley B. Moving forward, we know the mass of A, VAF minus VAI. This is where the delta in the momentum comes from because the mass doesn't change. Okay, it's equal to minus mb delta V of B. Okay, substituting in our values, we have 7.2 multiplying the final velocity of A minus 0.4, which is equal to minus 5.3 times the final velocity of B, which is equal to the final velocity of A. Remember this. Final velocity of B is equal to the final velocity of A because after they stick together, they move forward at the same speed. Minus 0, which is the initial velocity for B. This will then give you V is equal minus, excuse that, that is not a minus, 0.23 meters per second. There you are. 4.2.2. Alright, so 4.2.2 is asking us to calculate the average net force exerted by trolley A on trolley B during the collision if the collision time is 0.02 seconds. Immediately, this tells you to use the inertia formula, which tells you that the inertia F net delta T is equal to the change in the momentum. Now, remember, we are taking the convention that right is positive, okay? Right is positive. Now, our F net multiplied by the time, we are given the time as 0.02 seconds, is equal to the change of momentum, okay, is equal to the change in momentum. The change in momentum is given by m okay, I shouldn't have substituted there. Okay, that's fine. We'll have F net delta T, which is the impulse, is equals to the mass multiplied by VF minus VI. Right. Now, seeing as we are looking for the average net force exerted by trolley A on trolley B during the collision, we may thus use trolley trolley B, we may thus use trolley A. Sorry, we may thus use a trolley A to try and calculate the net force. Substituting our values, we have F net into 0.02 is equals to 7.2 into the final velocity we just found it is 0.23 minus the initial velocity of the trolley we were told is 0.4 meters per second. 0.4 meters per second. Thus, F net is equals minus 61.2, which is equal to 60.95 newtons to the left. Okay, there we are. Please do not forget to include the direction in the final calculation or the final answer of your calculations. So this should have a direction, whether it's to the left or to the right or up or down, and this should have the same, that should have the same, and so on and so on. But yeah, we are done with question 4. Moving on to question 5. Moving on to question 5. 5.1, we are asked to determine a non-conservative force. A non-conservative force is a force for which the work done on an object which is moving between 2 points depends on the path taken. So a force is non-conservative if the work done on an object which is moving between 2 points depends on the path taken. Okay, where your key phrases are work done and depends on path taken. Okay, work done on moving object between 2 points depends on the path taken. Okay, so a force is non-conservative if the work it does on an object in moving it between 2 points depends on the path taken. 5.2, using energy principles to calculate the speed of the crate when it reaches point C. I realize we didn't read the problem statement, so we will go and read it. An electrical motor pulls a 20 kilogram crate from rest at a point A up an inclined plane by means of a light inextensible rope. The inclined plane makes an angle of 18 degrees with the horizontal. B, C, and D are points on the inclined plane, and the distance between points A and C is 15.6 meters as shown in the diagram below. The motor exerts a constant force of 96.8 newtons parallel to the inclined plane on the rope. A constant frictional force of 15 newtons acts on the crate as it moves on the inclined plane. Now we are to use energy principles to calculate the speed of the crate when it reaches point C. Using energy principles tells us that the net work done on an object is equals to the object's change in kinetic energy. Okay? Now, the net work done will be the work done by the weight which is essentially the work done by the force of gravity. Okay, plus the work done by the friction plus the work done by the force, right? Which is equal to 1 over 2 m into Vf squared minus Vi squared, which is your change in kinetic energy. Okay, now for the work done by the force of gravity, we know that the work done by the force of gravity will be equal to mg sine of theta, because remember, as our the free body diagram for the crate may be drawn as such. It will have the normal force. This will be the first due to gravity. That will be the force applied, and that will be the force of friction, which is parallel, right? This is Fg perpendicular, this is Fg parallel. That is how you draw the free body diagram for that. Hence why Wg is the sine theta, because it is the perpendicular component. Okay, wonderful. So mg sine theta multiplied by delta x cos of theta, because this is the work done. Remember that the formula for the work done is given by let me use a different color, f delta x cos of theta. Cos of theta plus the work done by the frictional force. The work done by the frictional force will be the force of friction multiplied by delta x cos theta, plus we have the applied force multiplied by delta x cos theta, which is equals 1 over 2m Vf squared minus Vi squared, which is your change in kinetic energy. Okay, we know that the mass of our box or our crate is 20 kilograms. So we will write the 20 kilograms multiplied by the gravitational constant 9.8 sine of, now this sine is the angle which is given right there. Okay, this is the angle that the inclined plane makes with the horizontal. So that will be sine of 18 multiplied by 15.6, which is delta x, which is the displacement from A to C, because we are calculating the speed of the crate when it reaches point C. So the displacement from A to C is given as 15.6 meters, and that is our delta x. Cos of 180. Now the 180 is because of the direction in which we are applying our force. Are we applying our force in the direction of motion, or are we applying our force opposite to the direction of motion? that is what the 180 is for. It implies the motion of the force. It means that we are moving. It means that the force is applied in a direction that is opposite to the direction of motion, because remember that as it is moving up the incline, our box also has a upwards movement, because it's motion along the hypotenuse, meaning as it is moving up, it is also moving that way, and it is also moving that way. So this cos 180 is because the force of gravity is acting this way, which is opposite to the motion of our box in the vertical, which is up. I hope that makes sense. From there, we now do considerations for our frictional force. Our frictional force is 13.5 newtons. 13.5. newtons multiplied by displacement, which is 15.6 cos of 180 degrees, because again, remember, our the frictional force is acting opposite to the direction of motion. Our box is going in this direction, the frictional force is acting in that direction, hence the 180 in the angle. Then plus we have our force applied. The force applied is 96.8 newtons multiplied by the displacement 15.6 cos of 0 degrees. Now the force is acting in the same direction as the motion. The crate is moving up that way. The force is also applied in that direction, hence the 0 degrees, which is then equal to 1/2. The box has a mass 20, the crate has a mass 20, into Vf squared minus 0, because remember, at the beginning of the motion, the box had a velocity of 0. Working all of this out will give you Vf is equal to 5.96 meters per second up the slope. 5.3. Calculate. Oh, okay, let me give you a different version of how you could do this using a different configuration. Option 2. You could come and use the formula that tells you that the non-conservative work done is given by the change in kinetic energy plus the change in potential energy, where the work non-consecutive is given by the work done by the frictional force plus the work done by the applied force, which is equals to the change in, which is equal to 1/2m Vf squared minus Vi squared plus mg hf minus hi. All right, where this is your kinetic energy and this is your potential energy. Now the work done by the frictional force is of course given by the force of friction. It's given by the force of friction multiplied by delta x cos of theta plus the applied force multiplied by delta x cos of theta. Coming to our calculation, our frictional force is 13.5, delta x is 15.6, cos our theta is 180 because frictional force acts opposite the direction of motion, plus 96.8, which is our applied force, multiplied by 15.6 cos of 0, because our applied force acts in the direction of motion, into 20 into 1 over 2 Vf squared minus 0, because our object was stationary in the beginning. The 20 is the mass. I just factored it out and put it at the end there. Plus 9.8, which is our gravitational constant, into our final height. Our final height is going to be the length of our hypotenuse, which is 15.6 meters, multiplied by our angle, which is going to give you this right here. Remember that for a triangle, sine theta is equals to the opposite over the hypotenuse, right? And our opposite side is right here, and our hypotenuse is 15.6 and our angle is 18 degrees. Therefore, we may write our final height as 15.6 sine of 18 minus 0. Working all of that out will give you Vf is equal to 5.96. Although I reckon this method is easier to understand and it's much nicer to work with. All right, 5.3. 5.3, calculate the minimum average power dissipated by the electric motor to pull the crate from point A to point C. Okay, so from point A to point C, we know that our formula for power is given by the average power is equal to the force multiplied by the average velocity. Okay, and the force that it takes, the force exerted by the electric motor to pull the crate from point A to point C is given by 96 newtons. Okay, the motor exerts a constant force of 96 newtons parallel to the inclined plane on the rope in order to pull the crate up the slope. Therefore, our force will be 96.8. The average velocity is going to be the final velocity plus the initial velocity divided by 2, because we are taking the average of the velocity. So we're going to take the average of the velocity over the beginning of the motion and the end of the motion. So that's going to give us the final velocity. Okay, let's start with the initial. The initial is 0 plus the final velocity. We found that to be 5.96. So it should be meters per second divided by 2. Then the minimum power we find, the minimum average power we find to be 288.46 watts. You could also use equations of motion. Option 2. You could say delta x is equal to Vi plus Vf over 2 delta t, which is an equation of motion. It's just that instead of the usual y, we have an x there. Our delta x we know to be 15.6, which is equal to VI is 0, VF is 5.96 divided by 2, and we don't know delta t. Okay, delta t is thus 5.23 seconds. We take this and we plug it into the formula that tells you the power is given by the amount of work done over a certain period, which is equal to F delta x cos theta over delta t, which is thus equal to 96.8, 15.6 cos of 0 all over 5.23. Therefore the power is 288.73 watts. So the answer might range depending on what method you used for your calculations, but rest assured at the end of the day, your answer, if it falls within these two ranges of values, then you are totally and completely justified in thinking you are correct. Okay, let's go. Although I do think I favor this method because it's much easier, quicker, and less messy, because all of this is just a lot. So yeah, I'll just get rid of that. That is completely unnecessary. But for enrichment purposes, yeah. 5.4. When the crate reaches point C, the rope breaks. The crate continues moving up the inclined plane and comes to stop at point D. Okay. And then slides the plane past point B. Draw a labeled free body diagram. Draw a labeled free body diagram for the crate as it slides down the plane past point B. So as it passes point B, what is the free body diagram of our crate going to look like? Of course, it's going to have the normal. Okay. It's going to have FG, and it's going to have the frictional force. This is what it's going to look like. And you get your 3 marks. Finally, draw a velocity time graph for the entire motion of the crate, starting from point A until it passes point B again on its motion down the inclined plane. Okay, what is our graph going to look like? 5.5. Okay, let's draw that. We will have velocity in meters per second and time in seconds. Now, if we take upwards as positive, okay, it's looking for a velocity. The question is looking for a velocity time graph for the entire motion of the crate starting from point A until it passes point B again, starting from point A until it passes point B again on its motion down the inclined plane. Okay, so what does our crate do? It goes up the plane. It stops at some point, it reaches a plateau, then it goes back down. Okay, so now our velocity is going to look like something like this. Our velocity time graph will look something like this. Yes. Where this is the velocity at point C, which is 5.96. Because remember now, our crate is being pulled by a force up the slope, okay, from point A to point C, okay, meaning it's being pulled by a force. There's acceleration, so the speed is increasing up until it gets to a point 5.96, okay, which is at point C. Now from point C, our crate, the rope that's pulling our crate breaks, therefore there is no longer any acceleration, meaning acceleration is equals to 0. The velocity now starts, okay, acceleration is not 0, but the velocity starts decreasing. Okay, the velocity starts decreasing up until a point B. Now as the velocity starts decreasing, this is the point in the graph where you see the velocity start to decrease up until the point B. At point B, sorry, at point, is it point B or point D? Yeah, it's point D. Up until point D. When it gets to point D, it stops, okay? When it gets here, it stops and the velocity is equals to 0, which is the point where you see it crossing the graph. Now, the reason why there is a bit of a gap between where our graph hits 0 and where our graph speed now starts increasing in the opposite direction is because the change in direction is not instantaneous. It does not happen immediately. There is a little bit of time that elapses between when the crate reaches its maximum point and then it starts moving back down again. There is some time lapse between those 2 points, between those 2 moments. And now when our crate begins to slide back down, this is where you begin to see it start to pick up speed in the opposite direction. And that is the end of question 5 and the end of this video. Thank you for joining me.